So this is the graph, and here we have all the edges, all the directed edges, as this is the directed graph. So we are having the source vertex and the destination vertex here. Now let's create this class graph, and here let's first create the constructor where we will pass the number of vertices. So here let's define this dot number of vertices is number of vertices, and we're gonna take an array or a list which we're gonna call adjacency list. This adjacency list is a list of lists, and here we are going to take a for loop which will start from 0 till the number of vertices, and here inside this for loop we are going to initialize each cell of this adjacency list with another list or with another array. So here we will be having the index as the vertex and list of all the adjacent vertices to that vertex as the value at that index. So after creating this constructor, we're going to create function add edge to add these directed edges in this graph. So U is the source vertex and V is the destination vertex. And in the list present at U, we are going to push this vertex V as it is an adjacent vertex to vertex U. So if you're calling add edge for any edge 3, 2, then at index 3 we will be having list in which the vertex 2 will get inserted. And if you're again calling this add edge with 3, 4, then in the list present at index 3, 4 will also be added. So you will be having a list having 2, 4 at index 3. Now let's create the main function topological sort. And here inside this function we will create an array in degree to calculate the in degree of each vertex. So let's initialize each cell with 0. It will be having a length of number of vertices, and let's fill it with 0. So how we can calculate the in degree for all the vertices? Let's take this for loop which will go till number of vertices, and here inside this for loop we are going to find out the in degree. So in degree will be the number of occurrences of any vertex in all the lists present in adjacency list. So here adjacency list dot for each. So here we are getting the number of occurrences of each vertex from these lists. Now we are going to select the vertex that is having 0 in degree. So for that we are going to take Q, and here we're going to run a for loop till number of vertices, and now here we will check if in degree of any vertex is 0, then we are going to add it in the queue. So q dot unshift, and here it's gonna add this vertex I to the queue. So, and along with doing this, we are going to keep track of number of vertices that we have already selected. So let's take a counter C and let's initialize it with 0. And we are using Q just to store all the vertices that are having in degree 0, but we are not storing the result in that queue. So for storing the result, we are taking this linear order list. So here we will check if there are some elements in a queue, then we are going to shift, or we are going to get these elements from the queue, and we are going to push those elements in the linear order array. We want the vertex which got inserted first to come first in the linear order array. So that's why we're using unshift here. Now after this, we are going to run for each, and we are going to decrement the in degree of all the vertices which were connected to the vertex x. So we will go to the list which is present at x, and here we will decrement the in degree for all those vertices. And then we will find out if after decrementing the in degree, if the in degree of any vertex becomes 0, then we are again going to add it in the queue to be picked up by the linear order array. And then we will increment the counter. So after this, we're going to check if the counter is equal to the number of vertices or not. Because after the completion of while loop, it must be equal to the number of vertices. As till now, we would be having all the vertices in the linear order array. But if this is not true, if counter is not equal to number of vertices, then certainly there are negative cycles, or there is at least one negative cycle. So in that case, we are going to print graph contains negative cycle. And we will return from here. But if everything goes fine, then here we are going to print the result. So let's say the linear order is, and now we are going to print the linear order list. First, let's print element, that is the vertex, and then space. So now let's invoke the function topological sort, and here let's save this and run this. So let's say node topological sort, and here we go. So the linear order is this. So first we have 0, then 3, then 4, then 1, then 2.